Good morning, guys.
Good morning, sir.
Good morning, sir.
All back home safe. You played the roll of dice with your life and you're back home. Lovely. Good to see you. Homework kiya?
Homework partly I did, like classroom sum and one more I tried, but two sums I did not. I'll finish it today.
Only Bhavani email, WhatsApp me the homework sum. Others haven't, so I'm assuming you all haven't done. But if you haven't done, please do it. Okay. You can pay me the fine of $10,000 via Bitcoin. You are not completing homework. You have sent today.
Yesterday night.
So you okay? Okay, yesterday. Okay. So maybe I haven't. My data is not on yet. So I will keep my data on.
I
have.
I have Shiba Inu coins. If you want 1 million, I can transfer.
I accept everything. It's fine. I'm sure Shiba Inu will give me some money in the future. It's a long-term game.
Shiba Inu value is 0.1001.
Doesn't matter. See, there was this story of a guy who paid for a pizza in Bitcoin. He paid some 2-3 Bitcoins for a pizza because he thought Bitcoins would be useless. So just, you never know where the world goes. Okay, cool. So we'll wait. I think Tom has joined. Sanya joined. Sanya, you're feeling better?
I'm sorry, sir. I didn't hear you.
Are you feeling better? You left class midway yesterday. So,
Yes, I'm feeling better now.
so today we are just going to look at initially what briefly MLE is. I won't go into depth because you all already should know this. And then we'll look at Breslow's approximation to allow for certain aspects that are peculiar to our case. Okay, specifically to the case where more than one death happens at the same time. So in censoring, we saw 2-3 things. First thing that we saw in censoring was that censoring and death, if they happen at the same time, we are assuming censoring to happen immediately after that, after the death takes place. Then more than one death can take place at the same time point. And third, which we, just to reiterate it again, that censoring can happen before the first death happens or first insured event happens. Okay, so it's not like if the first insured event happens at time 5, that any time before time 5 censoring is not permitted. Censoring is permitted. So these are the 3 things that you must keep in mind. Now, because we're saying that more than one death can happen at the same time, in that case, does my MLE suit best, or is it something else that makes it or some approximation is needed to allow for it? Okay, so let's look at what partial likelihoods are, and then we will you can see my screen. There's some lag with my internet. You can see me. You can see the screen.
Yeah, we can see.
Yeah.
I can't see myself. The mini dashboard. Now I can see it. Okay, great. Is Bhavani's joined, right? Yes.
Yes.
Good. So let's start. Ria, can you please read?
partial likelihoods to estimate suitable values of the parameters bj for beta j for use in Cox model. We gather data on lights with different characteristics and use this information to write down the partial likelihood function. The partial likelihood estimates the regression coefficients but avoids the need to estimate the baseline hazard. For each life, we need to record the covariate values, the time spent in the investigation, and the reason for leaving the investigation, whether due to hazard being considered or otherwise.
So what does this mean? Whether it was actually the insured event or censoring. Okay. Next.
Each time a life is observed to leave the investigation due to the hazard being considered, we get the contribution to the partial likelihood of the form hazard for the life leaving the investigation at that time divided by the total hazard for all lives still under observation just before that time at risk group.
Okay. So basically what the denominator is exposed to risk that we're going to do in chapter 4. Okay. And I told you that there is something called as principle of correspondence in chapter 4. Principle of correspondence says that if it's there in the numerator, it must be in the denominator. Which means that if I'm saying that 5 out of my 21 IAQS hybrid program students secured all 7 exemptions. Okay. If I'm saying that, I cannot say 4 of them were from IAQS, 1 of them was from NMIMS. You understand what I'm saying? Because only those who are in my study are eligible for this exemptions, and hence if they are in the denominator, only then they can be in the numerator. Understand? Sorry, there's some disturbance. There are workers in the house. Sorry. Okay. So, where was that? Yes. So, if they are exposed to risk, which means here the exposure is that you have the potential to get the 7 exemptions. Only then you can get the 7 exemptions. Can I count that 1 student from NMIMS in that? I can't. So I should do 4 upon the 21. Understood? Yes. So here also it is saying that out of the 21, there will be many reasons. Say, for example, 5 got exemptions. Okay, we have removed 1 because NMIMS were not counted. 4 have got all 7 exemptions. And I can say that why am I saying this person is from NMIMS? Because maybe he left to join NMIMS midway. Could be. There are 2 other people who left the program because they couldn't handle the job and study at the same time. So total 7 people left the experiment. 4 of them were because they got the 7 exemptions. 3 of them were for otherwise. Okay. But my hazard, or in this case success, is only what? The 4 students. So I'm not saying 7 by 21 or 6 by 21, so on and so forth. I'm only saying 4 by 21. Understood?
But in denominator, should we include or exclude?
Denominator, if they were there at the start and they left because of censoring, and if they left after certain amount of time, and this is not the best of example, okay, because people who left in between won't be eligible for the 7 exemptions. But here, assuming if they left or got censored immediately after the event, then they must be included for the entire time period. If not, then they should be included for the exact time period. Now, how to calculate exposure based on exact exposure, based on approximations, based on trapezium approximation, census approximation, all this we will do in chapter 4. Okay, for now, you understand the concept that if they are there even for some time, we will count their exposure till that time. It's not fair for me to count it for the entire 2-year duration of the course, but at least that exposure will be there for some time. Clear? Same thing that we did in Kaplan-Meier and Nelson-Allen. Till the time they got censored, they were included in the NJs. The moment they got censored, then the next NJ, they were excluded. You remember that, Ashok? Yes?
Yes, sir.
Cool. Okay. So now, does this work for, maybe this may work for overall how many ever deaths happened, but does it really account for individuals exactly? Does it account for, is it complete? Is it holistic? Is the question that we will see now. Now, how do you, from here, how do you go to maximizing your partial likelihood? Let's have a look. Kaustubh, please read.
Yes. We will now consider how to estimate the regression parameter beta, that is beta 1, beta 2, and so on, to estimate B in the Cox model. It is usual to maximize the partial likelihood. Like, let RTJ denote the set of lives which are at risk just before the jth observation lifetime. And for the moment, assume that there is only one death at each observed lifetime. That is dj equals to 1 into 1 less than equal to j less than equal to k. The partial likelihood is L beta. So how to read this notation? After equals to
L beta is the product.
Product j equals to 1 k e raised to beta z t j by
E raised to beta z j transpose.
Divided by summation I r t j.
I belongs to R.
I belongs to R into tj e raised to beta
R of Tj. R of Tj.
R of tj
Or R.
into e raised to beta z I transpose what you said. Intuitively, each observed lifetime contributes the probability that the life observed to die should have been one out of the RTJ lives at risk to die. Conditional on one death being observed at time tj, the maximization procedure is usually carried out using a computer.
Okay. So here I'm not asking you to solve the sum, but this is how we will look at maximizing the partial likelihood. Okay. Now coming to the point, very important point in the previous slide, which says, because what is this chapter about? Removing the time dependence. Okay. Second line, very important. Partial likelihood estimates the regression coefficients, but avoids the need to estimate the baseline hazard. Because the moment we get into baseline hazard, that becomes complicated. Yes, then it is a function of time. Yes, but the problem with the maximum partial likelihood creates is the fact conditional on one death being observed at time tj. How many people are born in India every day?
Maybe some millions.
Yes. So more than one death can happen every day, more than one birth can happen every day. Is it only 365 people are dying? Every day 365 people are being born every year.
No.
Nothing like that, right? So the drawback of this is that this only allows for the fact that one death will happen. Even in first small experiments that we saw, sometimes at a specific time interval, because we're doing interval censoring and interval mapping, in that case, what happens? More than one death happens at the same time. So then is it giving me the best estimate here? No. So we need to do something called as Breslow's approximation to the partial likelihood, which helps me allow for more than one number of deaths at that same time interval Tj. Because we saw that in Kaplan-Meier and Nelson-Allen sums. Yes, that it can happen. So Ashok, read this part.
Breslau's approximation to the partial likelihood. If there are ties in the data, that is, the death times are not distinct, then Breslau's approximation to the partial likelihood can be used. So L beta equal to product of K j equal to 1 e power beta s t to j divided by sigma I belongs to R small tj multiplied with e power beta z ti whole to the power of dj.
It's not multiplied by it. Submission e raised to beta sj transpose upon the submission I belongs to RTJ, e raised to beta zi transpose the whole raised to dj in the denominator. Now, why raised to dj? Because that is the number of deaths that are happening. So for each death, I'm allowing for that exposure, because each death was exposed to that risk, right? If there were 100 people and there are 5 deaths, then that is 1 upon 100 into 1 upon 100 into 1 upon 100 into 1 upon 100, right? So everything is exposed to that. Independently, the deaths are happening. The deaths are not interlinked. Okay, continue.
Yeah. So where Sj is the sum of the covariate vectors Z of the dj lives observed to die at time tj. Sorry, Sj is the sum of the covariate vector Z of the dj lives observed to die at time tj. Dj is the
Number of deaths.
Number of deaths. Okay, at time tj. Sj is the sum of covariates. The maximum partial likelihood estimator of the vector of parameters b, which we denote by b bar
B tilde
approx. Okay. So the maximum partial likelihood estimator of the vector of parameter b, which we denote by b tilde, will have asymptotic
multivariate normal distribution.
Okay, asymptotic multivariate normal distribution. This approximation tells us that all lives leaving the investigation due to the hazard at given time should be included in the at-risk group used for denominator of each life's contribution.
Okay, so here what is asymptotic multivariate normal distribution? Nothing for you to know much. We're not going to go in depth because this is just for your understanding. What the main purpose of this is to tell you that if I am doing a partial likelihood estimate and I want to use Breslau's approximation, the reason I'm doing that is because I'm giving each of the deaths the same exposure, right? By doing that, how am I doing that? I'm doing that by raising the denominator by dj. Dj is what? Number of deaths that have happened at that time tj. Clear? Okay, so let's look at a sum where we create. Now, you don't have to solve this sum. You just have to create an equation for this and solve the equation as much as you can. Okay. And please message me on WhatsApp as and when you finish. So basically it is saying, note, take this photo of this so I can take you back to the previous slide so you can see the formula and you can write it. Now apply your learnings from earlier chapter and do it here. Okay. I'll read out the question for you so that there is no ambiguity in understanding what the data is. Okay. An investigation was carried out into survival times measured in months of patients in hospital following liver transplants. The covariant Z1I is equal to 0 for placebo, 1 for treatment X, and Z2I is equal to weight of patient measured in kgs. Okay. The observed lifetimes with weights in brackets were as follows. So this means that the person survived for 3 months and he was weighing 83 kgs upon death or during death, whichever you want to consider. That's irrelevant here. Then treatment X and placebo. Everyone knows what placebo is. Those who don't know, raise your hands. Everyone knows what placebo is. Ashok doesn't know what placebo is. Okay. All right. So placebo. Okay. So there are two things. Okay. Like how we said at the start that, you know, we want to take a ratio of hazard. Okay. I'm saying that I gave the example yesterday. Kaustubh and Ashok. One is part of group study. One is part of self-study. And those are the variables that they are looking at. And then that results in Ashok having a chances of say 5% more of passing the paper versus Kaustubh, or the other way around. Okay. Now, what does this mean? This means that I am measuring Ashok's performance, keeping Kaustubh as the baseline. Yes, Kaustubh is 5%, or Ashok is 5% less likely to pass as compared to Kaustubh. So Kaustubh is the baseline. Correct? Here, similarly, what happens in any drug trial is they'll come up with an experimental drug and they'll say, okay, this treatment has 30 people. Okay. Out of these 30 people, 15 will be placebo, 15 will be treatment X. X is that drug. Okay. So what is placebo? Placebo means that the 15 people will just be given normal, plain glucose powder. IV. You know what you get sometimes when you're dehydrated or something, they'll give you IV infusion, just the plain electrolytes or whatever they're called. Yes, but no one will know. Okay, the drug will look like the IV bag, same. Labeling will be same, color will be same, feel will be same. Nurses don't know, doctors don't know, but effectively they're being given sugar pill. How many of you know homeopathy? Yes, sugar pill you get and then they infuse it with something. So when my mom used to take homeopathy as a child, I used to be like, why are you getting all sugar candies? Even I want. So she used to make one for me also, but that never used to have the drug. That used to have the sugar pill only. So that is placebo. Now, what is placebo? Placebo is I'm not giving you the drug, but I'm not even telling you that I'm not giving you the drug. Okay. And you see the mind is so powerful. And this is a coined phenomena called the placebo effect. Okay. Which means that patients recover because they feel that they are being treated. Yes, this is a true story that happened with my cousin's best friend back in college. Must be 15 years ago now. he had torn his ACL or meniscus tear, something had happened. So he went in for a surgery. Okay. When they gave him anesthesia, he reacted and he was clinically dead for 45 minutes. Okay. All the doctors did during surgery was to help revive him. Okay. And then they said we cannot proceed with this thing. And this was an emergency hospitalization where immediate surgery was warranted. Okay. Lots of pain, lot of this thing. But now surgery never happened. The knee was not even touched. Okay. When he came out and people asked him how your feeling was, people were scared that, okay, they had to disclose that he died. We couldn't do surgery, overdose of anesthesia. He said, yeah. Now my leg feels better. The pain has gone. Okay. The leg wasn't even touched. Okay. This is called the placebo effect. Okay. So similarly, patients feel that they are being treated for cancer or any of these things and they feel better. Now, who knows about this? See, say for example, if I'm doing this with you guys, okay, there is some brain performance enhancing drugs. And I'm telling that, okay, come to IAQS, we are giving you that, you will get all exemptions. But I'm doing an experiment in which I have to give only 10 of you and 10 others I can't give. I'm saying I'm giving, but I can't. Okay. Now, say for example, Mumbai University has designed this experiment. Okay. And they tell me, Vivek, okay, you give 10 people this drug, your choice. First of all, what will happen? I will say, okay, let me see. I will say, okay, maybe Kaustubh, Ashok, Riya, Tom, Bhavani attend my lectures almost every time. Two things can happen. I'm like, if they are attending, let me give them for sure. Or I can say, you know what? They attend, so they will pass without that also. Let me give it to the ones that are not coming. What is this creating? This is creating a bias. Okay. So first of all, I will not be in control of the experiment. Okay. Secondly, once I start giving, okay, now by mistake, they have given me control of the experiment. Okay. Then I see, oh my God, those guys who are not attending my lectures are getting 90% and these guys are getting 75. Then I'll say, let me switch it around. Okay. So what am I doing? I'm creating bias and manipulation in the trial itself. Okay. So I will not be allowed to choose. In fact, Mumbai University has designed this experiment. They will not even tell me who gets what. So similarly, the nurses and doctors don't know who gets what. Why? Because they will, if they know that this guy is getting placebo and they see that this guy is dying, they'll be like, you know what? Let me try and save. Let me switch this out. And this patient who's getting that, let me give 2 packets to him. But what is that? This is reducing the efficacy of my drug. Okay. So until I have the base of placebo, I will never be able to measure the efficacy of my drug. Okay. So this tells me that one is placebo, the other is treatment X. Okay. Placebos are not getting the drug, treatment X is getting the drug. Okay. What does 383 mean? Means he survived for 3 months after liver transplant and he was weighing 83 kg. So she was weighing 83 kg. Okay. Wherever asterisks are there, that means they got censored. Now you have to determine using Breslow's approximation the contribution to the partial likelihood that is made by the deaths at time 14. Okay, so I just want you to write all the equation down using this formula. Okay, you have taken photo for that previous sum. Yes? Okay. Start. Done, Ashok?
No, sir. I'm just thinking how to write this equation.
See, it is just the hazard that you know, H not T, E raised to whatever those characteristics are for death in the numerator.
So
And
these
for
all are.
everyone,
So here all are deaths only, right?
no, not everyone. Not everything is death. First of all, you need to look at time 14.
Okay.
Okay. When you need
But
to look at time 14, then some of them would have already been censored, so not part of exposure.
yes.
Yes. And then whoever remains need to be in the denominator. Whoever has died needs to be in the numerator. So basically, you're just writing the same equation, H naught T E raised to beta Z i's. And that's it. Upon numerator, upon denominator. How you write that is up to you. I need it at time 14. And you've been given the times available in the sum. What time, what happened. You'll have cross-checked each other's answers. Riya, Bhavani.
Yes, sir.
They're matching.
Yes.
Okay.
So we had a doubt in the last part of question number 3.
I am looking at that only. In that you have written Z3 twice. That is wrong. Z3 becomes Z4. The second one. Okay. So then you have beta 1, beta 2, beta 3, and beta 4. You can't write 3 values of beta 3. And in betas, you don't need to do 0, 1. Beta is just a value. You don't have otherwise. All that is wrong. Okay. See question number 2 that you have done. In that, you have written beta naught only once, right? Beta naught, beta 1, beta 2. So in beta 3, in question number 3, why have you written it as beta 1 is equal to 0.25 for male, 0 otherwise? You don't need to write that. That's only for ZIs. Clear? Also, the confidence interval is 0. Where is the confidence interval 0? How can the interval be 0, Ria? Passes through 0.
Yes.
Confidence interval को ही 0 बना दिया.
So,
Yes.
I had a doubt in this question.
Yes, ask.
They've given the time as 14. So, like, should we take only the value?
Okay. I'm not answering that question. I will message you.
Okay.
Let others.
On numerator, it is product, right? We have to multiply all.
Yes. The entire thing is product of.
In numerator, there is a sum, no? Like numerator will be same across.
Yes, but raised to DJ.
Yeah. Indeed.
Yes, Kaustubh. You asking something?
No, sir.
Bhavani, when you're writing the answers, first show the default formula. Don't directly show the first step. First show what is the H naught, HT is equal to H naught T, so on and so forth. Right? Just don't directly write the from the start. Okay.
Okay, sir.
Okay. So that is. Okay, any specific doubts you have, Bhavani, in the homework? I think it's fine. It's just that we have told you a few things. Apart from that, any doubts you have before I delete your?
Sir, in the
Yes.
second question, I didn't write the last part because I didn't know how to write. So that's where I
What
had
is the question? I've not seen the question. I'm just looking at your things and since you both have the same answer, I'm not checking whether the calculations are correct. I'm looking at whether the way you write, the way you have done it is includes all steps. So what is that question? Tell me the question.
Yes, sir. I've sent the question like,
Is it the one where beta is equal to 0? So what to do? That one.
it is like set out how you would determine whether the effect of any of the factors depends upon any of the other factors.
Okay, so this is on correlation. Okay, what was the question about? I've not seen the.
Yeah, I'm sending the questions.
Yes, yes. Priya, for you, any specific questions?
Sir, the same question is Bhavani answered.
Okay. Tanya, I don't know what square root of V is. Variance is not called V. Okay?
Oh,
Don't
okay.
take shortcuts. Are your answers matching with the others?
Yes, sir.
You have gender, volume, area of residence, city center, city center. So this is from your past, this thing. From probability in statistics, you will have to look at some of the things that you have done. So your which was that? 2016. Others, have you finished? Breslow sum. Yes, this should have been taught to you in probability and stats. Likelihood ratio test. -2 upon L without interaction, -2 L minus L with interaction. Okay, this is one way to do it. And the other way that I've taught you, once you either do it using the chi-square distribution, which is tougher to do, or you use whether the confidence interval has 0 in it or not. But you have to, and this is a theory question. So this is asked across a lot of sums. I think 2-3 sums like this will have this question on likelihood ratio test. Okay. Did you all not learn this in probability and stats? No?
No, sir. No, sir.
It's there in your portion.
Yeah.
Okay, so revisit that and see. Who taught you PS?
There was a guy called Manav.
Was Mardia.
I don't know whether still he's there because in the last classes he did not join.
In last classes, he didn't join as in.
In the sense there was a revision classes which we requested, then he could not turn on. I don't know what's wrong with that guy.
Okay. Right of Akasha. Someone else turned up or no? Or you didn't get revision?
And also the
So,
this topic was
doubt solving, always the faculty is not necessarily they show up. Okay, so even for my doubt solving, Kinjal shows up. Okay, so if I do the doubt solving, the reason for that is that you get a viewpoint of someone else as well. Okay, so even for my revision lectures or my lectures where you have doubts, Kinjal shows up. Usually there are no doubt solving in my this thing because I do a lot of sums anyways, right? So usually you don't need it, but if you need it, then you'll have Kinjal show up as well. So don't kill me off in the next semester, Ashok. Vivek was there. He didn't show up for revision lectures.
No, last time two lectures took complete PS, and I have asked for my paper. How I have attempted. So the portion which Bhavya sir did, I scored well. Like I scored more than 65%. So the portion which Manav, taught, I scored 0 completely. I mean, it's.
Okay.
I'm not blaming him, but thing was that I was not clear on the concepts which he taught, but I was cleared on what Bhavya sir taught.
Okay. Noted. So you all have a feedback as well, right? So even for me, you would have got some forms to fill. Yes, no.
Not yet.
After the SEM one, yes, there was a feedback. Yes, I think so.
Okay. Okay. So maybe we'll get that feedback rolled out earlier so that we know midway only what's working, what's not working. But again, see, please understand this, that sometimes, of course, they don't disclose to us who the feedback is from. Okay. But if you are not regularly attending, like for my batch, I know that 5-6 people attend. Right. This is and Sanya shows up sometimes. Manav shows up once in a blue moon, and then Abdel shows up sometimes. Okay, but it's just the 5 people. Okay, so if you guys are genuinely saying you're not understanding something, then that's why I asked in class rather than feedback, because I am not one of those people who will say, oh, Ashok said that I didn't explain this to him properly. It doesn't matter. For me, it's actuarial control cycle. You're telling me something, I will take that feedback, I will do better. So you might as well tell me if there are some things that you're not understanding. And sometimes I know that I'm going to teach that in the future, so I don't go into that at that moment in time. Like I spoke to you about exposure today, because I know in chapter 4 that question is going to be answered. Right? Apart from that, if you have any feedback, especially the ones who come regularly, feel free to just directly tell me. Happy to address it. Okay, rather than waiting till the end and seeing that my marks are not there. Right, so we don't want to be that your marks are compromised in any way.
No, there are a lot of reasons in SEM 1 why it did not well. I mean,
yeah, so you all also need to show up regularly, right? Because no one forced you to sign on to this course. Now you signed up yourself. Then you have to show up. Yes, now Ria is going to give me feedback. Yes, Ria, please go ahead. I'm ready to listen.
So actually not the feedback. I was thinking like what test do we have to like do here? I didn't get this. in this
Okay, so this is okay. So here, you are saying that there are interaction. Okay, so let me give you a real life example. In life insurance, you and I think I discussed this as well. You don't allow for alcohol consumption as a rating factor. Okay, you just ask the question that is it excessive, and if it's excessive, it will trigger more blood test. Okay, more investigation. But till then, it is assumed that all impact of this is included in smoking. Okay, so usually people who smoke drink. Okay, and if you're smoking, the premiums are already allowing for it. So basically, that's a level of interdependence on the two. People who drink more smoke more, or people who smoke usually also drink. Okay, unless it is a matter of faith. So in some cases, if you see Muslims, they don't drink, but they smoke. Okay, so that's an outlier thing that we're not talking about that here. Okay, but usually the interaction exists. Okay, so that is what the question is asking you. And I told you yesterday or day before, whenever we were having the earlier classes, that there is nothing called as IIDRV, independent and identically distributed random variable. So there is always a level of dependence on certain things. So here it is telling you to theoretically tell me what is the way I can figure out if there is an interaction or interdependence between the two covariates. So this test helps you determine that. And in PS also, there was a chapter on level of significance. You would have learned that there. In short, in practical aspect, it means that if I add one more rating factor, and if it increases my output by from 98% to 98.1%, should I complicate my model? Because that level of accuracy is not worth the effort I'm putting in. That is what you learned in level of significance chapter. Yes, this is also what you are looking at. Interactive terms. And if there is dependency, and this is the formula this is the test statistics to check it. So the log likelihood without interaction and with interaction. The difference between the two into -2 gives you the value of the test statistics. If this breaches my threshold or this lies in the critical areas, or if my confidence interval does not pass through 0, that means that there is some impact of it. Yes? Understood?
Yeah, but sir, like this test statistic, like I am not aware of this test statistic. Where did it come from? Like,
It came from someone. I don't know where it came from, but
and how do we write it? Like we didn't do any kind of test like this. I don't
okay,
remember.
so that's what I'm saying. It should have been included in your probability and stats. Every year, students come up and ask me if this was done. Every year, I say this is part of your portion. In fact, this year only I cross-checked, and they said it is included in the portion. Sometimes what happened, past papers, the portion changes, so they're not included. So it's removed. Okay. But as far as I know, and I checked this time, it is still included in your portion. So should have been taught. Now, if I tell you something directly from the middle of that chapter, I will not be able to explain it in the best way unless I set the context for the entire chapter for you, which I cannot do currently. Okay. So for you, you have to understand that the test statistic itself is like saying that I have a chi-square test. Now, you don't ask where that chi-square came from. No? It's a chi-square test. This is a log likelihood test for which the test statistic is -2 into log likelihood of the without of the original minus the log likelihood with the interaction. Understood?
Yeah,
Okay.
so I remember like we did the log likelihood function, but we didn't do the test for log likelihood. So
Okay. So here also you're not doing the test. You are just kind of rote learning this formula. Beyond this, you don't have to write anything. You're not actually performing the test. Understood? Unlikely this is asked. Unlikely. But that doesn't mean it can't be asked. Okay? Go back to that chapter in which you did and see if there are sums on that. Okay? Any more questions on this?
no.
Okay. Okay. So Ria, Sanya and Bhavani have checked. Kaustubh, please send me. I will check yours later, Kaustubh.
Yes, sir, I have sent it.
Okay, now coming to okay. Bhavani has sent me 143B2. Where are your H0 T's, Bhavani? You don't like H0 T? Where have they gone? Directly, if I have to cancel them, sir, why do I show the effort of writing it?
Sir, I forgot.
You forgot. Very conveniently, I'll also forget to give you marks. Yes, others, have you sent me the sum? Solution? Also, you sent the homework sum or you sent this sum currently?
This sum, sir, not completely, but until I could understand.
Yes, but you haven't solved the sum.
Yes.
Finish it, finish it. It is just writing the equation. Let me show you. I'll give you a sneak peek. I think the problem with you guys is you all don't know where to start. Okay? I'll just give you a sneak peek. Huh? Pay attention. 3 seconds I will give you. Count to 3 and I'll change this line. 1, 2, 3. Done. So now you saw there were equations of the form h naught t e raised to whichever beta 1, beta 2, however we write. So that's all you need to write. Then you have to find if there is something common, you take that common out and cancel it. If there's nothing common, you don't. You just finish that equation and leave. That's all. It's a two-step process. Clear?
Yes.
You need to be at time 14. How many people at time 14?
There are three. One is censored and two are there.
How many people are exposed at time 14?
Uh, Four, I guess. Yes, four.
4?
Yeah.
That's it. Write it. Okay, first write down for all the four people each equation in the form of how you write HT. How you would have written HT for each of these four individuals which are exposed to risk. That goes in your denominator.
But at time 14, there are only three cases, right?
What you do with that is your choice. So until you do and make that mistake or do it correctly and send it to me, how am I to check? I told you guys, don't get stuck in your heads. Ashok, you specifically. You
No, no,
first visualize the sum in your head and then you start solving. Take your pen and paper and start. Start. Don't think too much. Don't overthink. And I'm telling you, write down each equation. Start writing them. It will flow. The answers will flow. There are 3, 4, whatever it is. Write something down. Yes, Anya, you're done?
No, sir.
Suddenly your voice was very loud. Super speakers you're using.
Sorry.
Tom, you're there today? No word from you.
I am traveling, sir.
Okay.
I'm in Chennai traveling, OMR.
Okay.
That's why I couldn't actively participate. I was just hearing your lecture, listening
No
your
problem.
lecture.
Okay. No worries.
So I like made the equation, but I don't know how to like express those in words. Like
Why do
what
you need to express in words?
like I had a question like in the questions that we solved yesterday as well. So what needs to be expressed in words? What important things are there to be expressed?
So some things that you're doing. So say for example, what you guys are not doing in some cases, you're not writing the formulas at the start. So say for example, you're not writing that the hazard function is defined as ht is equal to h naught t e raised to beta zi. Right? That is missing. Then in some cases where you need to comment, for example, that in this case, when you say that what to write. So here you will write that 3 people were impacted during time 14. One of them was censored. So assuming that one censoring happens after the 2 deaths, this is the Breslow's approximation. Or Breslow's approximation is given by this. So this becomes this. You understand? Yes, send it to me when done.
Yes, sir, I sent it.
So Ria, I've checked yours. It's fine. Just write the Breslow's approximation formula on top. Okay, we'll see how it is done now in some time. Let me just check. So Ria and Bhavani, other things are all done. Anything else before I delete your images? My phone storage is almost full.
No.
Okay, so those who are not sending me, if you don't send me, I cannot capture your mistakes. If I can't capture your mistake, then you will get penalized in the exam. Might as well send it now so I can check it. Again, Bhavani, some of the things that you need to mention, we'll see now.
Okay, so I recent by writing the baseline hazard.
Yeah, but don't write numerator, denominator, all these things. What? Kids or what? Well,
Why like why easy to not make mistake I wrote like that.
no, but then that just shows now you're underconfident. See, you think of it this way, no? You don't want to pretend to be. There's one thing about being thorough. The other thing being making it sound very kiddish. Yeah. So don't do that. Okay, answer is correct. Okay, others who have not sent me, you'll see the answer now. See how they have written. Okay, so here it says just before time 14, there were 4 lives at risk. The total force of mortality for these 4 lives at time 14 is mu naught 14 e raised to 75 beta 2 plus mu naught 14 e raised to beta 1 plus 68 beta 2 plus mu naught 14 e raised to beta 1 plus 49 beta 2 plus mu naught 14 e raised to 86 beta 2. Now, where most people make mistakes, most people make mistakes here. They will write it as H naught 16. Okay, this is still H naught 14 because we're still at time 14. Do you know this guy is going to die at 16? You don't, right? So this common error, how many of you made this error? Ria and Bhavani didn't, but Fatima, sorry, Tanya, Kaustup, who made this mistake? Ashok?
No, I did not make that mistake. But yeah, I did not consider. I have taken only the 14 one because I was calculating at 14.
Yes.
Only 3.
So at 14, they're still exposed, no? Person is still alive.
Yes.
Yes. Do you know at time 13 that at time 14 these 3 will die and that 1 will not die?
Don't know.
In the
So-
denominator, exposure is there, no?
Yeah. He was still alive by the time. So
Yes. Yes. Sanya, what about you?
I couldn't start, sir. I wasn't getting the starting point.
If you weren't getting Sanya, you need to ask, no?
Yes, sir.
First of all, you don't keep your cameras on. So I don't even know if you're confused, not doing. Okay. I understand you may not be comfortable keeping it on. But if you are not giving me the tools to help you, how can I help you?
Yeah, I just made the denominator as you said, but I just couldn't.
But ask, no? What is stopping you from asking? Am I not answering your questions? Am I saying I will not answer your questions specifically? Or you're not allowed to ask questions in my class? If
No,
you
sir.
don't ask, these people are, I can see Ashok when he's not writing, I know he's confused. I can see. So I ask him. Ria is thinking something too loud, and I know that, okay, she's not understanding. I can ask because I'm able to see them. If I can't see you, I don't even know what you're doing. Okay. And if, okay, you keep your cameras off for whatever reason, but then at least ask, when you're confused. Just don't sit there. It's not going to be helpful for your career.
Yes, sir. I'll ask from now on.
Now, who takes a poll with me that she'll not show up for the next lecture? We'll do a polling. Sanjay, when I'm not coming.
No, I
Yes,
will
Sanjay.
show up next time.
Okay, we'll see. Right. I'll keep a surprise lecture. You see. One day I should just enter in Akash's lecture and see how many people show up there. Then I'm like, great. Cool. So here, like I said, 4 people were exposed. You don't know at time 16, so you need to keep all 4. The numerator will only have 1475 and 1468. The denominator will have all 4. Raised to DJ. How many DJs? 2.
2 death cases.
Clear? Clear?
Yep.
So it's not rocket science. Very simple. You just had to write the formula, and both of you, Bhavani and Ria, read, and everyone read how they have written, so that you know what all to write, not just the direct steps.
Instead of mu, we can write h naught, no?
Sorry, what?
Here the mu was what written here, but h naught we can write.
Mu naught, h naught, lambda naught interchangeably used depending on examiner. Same thing. Just don't write ht here and then mu naught here. Same. If you're writing ht, h naught t. If you're writing mu t, then mu naught t. Lambda t, lambda naught t. Clear? And the lambda is small lambda, not the capital lambda that we did for Nelson Allen.
Yep.
Clear? Okay. So with this, the chapter is done. Okay. You have done enough sums to, I think we did this sum. We did this part as well. Yes, so we covered everything in this chapter. So this chapter is done. Please note that in this chapter, the trick and the confusion will only lie in sometimes determining whether you're talking about survival or hazard, or survival disguised as hazard. If survival is disguised as hazard, nothing you can do about it. Okay, you have to treat it as hazard only. But in the mixed sums that we saw of chapter 1, within this chapter, if they are giving you TQX, the formula still is of TPX. So if the survival is disguised as hazard, it is still TQX. You need to make sure that if you are using the TPX formula, that you do 1 minus TQX. Okay, so you'll need to be able to identify which is what. So reading this in the first 3 chapters, reading and understanding and reading between the lines is very, very important. See, maths you can do. Once you get the flow of it, you can do. But starting is the problem. Understanding the question is the problem. Okay. So please make sure you do all the practice questions that are there. Ones I've covered, ones I've not covered, you should be doing all of them. In my class, I cover the ones which are not in your practice questions also, so that you get exposure to even previous 5-6 years of papers. And then you can do 7-8 years of papers, 10 years of papers, so that your exposure is across 10-15 years. Different type of sums that can come. Yes? Clear? Okay. Any questions in this chapter? No? Okay. So now, in going forward, we'll be skipping to chapter 6 first. Okay. So we'll start off with chapter 5. We'll do 1-2 slides from chapter 5. Then we'll finish chapter 6, which is the theory behind graduation. And chapter 5 then talks about the what to do after I've done the graduations, which are the tests for graduations. Okay. And then we will come back to chapter 4. Clear? And then after chapter 4 is done, we'll switch to unit 4 as well, which is your last chapter. Okay. But most of the sums, so chapter 6 has more sums, chapter 7 has 1-2 sums only, not more, 2-3 sums max. So the bulk of the practice is in chapters 2, 3, 4, 5, 6. And when I say 2, 3, that includes your chapter 1 sums as well, because usually always asked as part of the mixed sums. Okay. So, and that's the important part to understand about actuarial science, that you have to remember everything you have done. Okay. So like you are seeing, there are some aspects from from semester 1, like how to make confidence interval, how to make all these things. They asked here. Because actuarial science assumes that what you have done in the past, you must remember. You must apply. Yes? So don't control alt delete or shift delete what you did in Sem 1. Okay? Very, very important. Any doubts in this chapter?
So, do we expect a 15 marker from this chapter?
Yes.
What we have practiced is like lengthy questions, what we have seen. So I thought.
Yes, yes. 15 mark questions can come. Yes, Ria?
Sir, I just had a small doubt. Like I got confused yesterday. So
Okay.
while doing the confidence interval, while we test whether the particular hazard is not applying, it's basically when we see whether the particular thing is like significant or not, like that test we did. So, like, what was the like inference for that? Like I got confused in the inference, rejecting the null hypothesis.
Yeah. So, okay. So there are two ways to look at it. One is whether it lies in my confidence interval. What is confidence interval? As the name suggests, I'm confident in my answer. If it's this in it, that is the 95% confidence interval. So when you do it as per that, it should lie within the range of minus 1.96 to plus 1.96. If it is a normal approximation, which in most cases is right. If you're doing it on a chi-square basis, chi-square based on the degrees of freedom has its critical values that we get from the table book that we will see in chapter 5, and you would have already seen in probability and stats. Okay, slightly different here, because here the way we write in probability and stats, you would have done chi-square as chi-square with degrees of freedom n minus k minus 1. Okay, K is the number of additional estimated parameters that you have had. Here, because we don't compare individual graduated values, we look at the curve itself. We do it on the basis of chi-square n minus k. Okay, that's the only difference. And sometimes we don't know how many parameters are estimated. So basis that, we'll have to check when does the threshold get breached. Okay, so that is the critical value for chi-square. Then for normal, I said that we do 1.96 plus 1.96. In the third way of doing it is with p-value. Now, p-value means that my probability value shouldn't lie in the tails. So that means that my probability value shouldn't be less than 0.05. Okay, which is the 5% of my tail. So 2.5 this side, 2.5 this side. If I get the value lying in the tails, what is a tail event? Tail event is an event like a COVID. Do you want that exposure in your product? No. So if the p-value is that, then I will certainly reject the hypothesis, whatever that hypothesis will be. Understood? So these are 3-4 ways that you assess level of significance. Now it depends if it's a one-sided test, two-sided test. If it's one-sided, then the value 1.96 plus 1.96 changes, right? So those things I'm not getting into, but you already know that. Right tail test, left tail test, which side, all of that will depend on how you go about the finding that value. But you understand. And then in probability and stats, you would have also done T. So here we're talking about Z values. You also would have done T values, right? So those things all, but here in going forward, because we deal with a lot of large numbers, you have to understand that most things get approximated to normal. Yes? Clear?
Yes, sir. So basically, like we did the sum for the beta is equals to 0. So that was the null hypothesis, right? We are testing
Yeah. So
whether
yes. So while you have not defined the null hypothesis, the question is asking you a hypothetical null hypothesis, and you are saying that I'm going to I don't have sufficient evidence to either reject the null hypothesis, depending on what the question is. It depends on the type of question. But in most of the times, you say if the confidence interval passes to 0, this means that there is some evidence to prove that what I'm saying might be true. Hence, I cannot reject it. Because 0 means what? Equal. What is null hypothesis? Equal. Yes. Alternate hypothesis is not equal. Yes. Clear? And of course, you would have done in hypothesis testing as well, power of the test, alpha and beta, type 1 error, type 2 error, that you would have already done. Yes? Clear? Okay. Why is Abdel not joining? Yes. Can you check? Next time, Kostu.
Probably is
Yes,
fasting.
sir.
Ramzan, right?
Fasting at the time difference, it is around 3:30 in the morning for him. And that some iftar or sehri time is there, right? So
Okay. Cool. So we'll close here. We'll do chapter 5 introduction and then chapter 6 going forward. I may take the Sunday lecture currently for which the slot is open. Not sure, but if it is, then Muted myself by mistake. Okay, cool. So either Sunday or then otherwise next week. Okay, but that chapter, those two chapters will get over in like 5-6 lectures. Okay, so if you snooze, you lose. It'll be done before you know it. And that chapter has the highest likelihood of a 15-mark question. And that's the
The next chapter,
easiest.
the graduation is what you say.
Graduation, yes, 5 and 6. Okay, so don't miss.
We will aim for graduation with the graduation.
Yes, you've come for post-graduation, just FYI. Okay. All right, guys. Thank you for your time.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.